Okay, the purpose of this video is for me to demonstrate the functionality of our circuit that we built in Quartus for lab number 1. We already have our program downloaded into our DE0-CV board, and we're going to run through some examples showing the functionality. For my particular implementation, I'm using switch 0 as my adder subtractor select switch. In the down or off position, it's set for addition. So we're going to run through the addition examples first, just to show the functionality. So our first problem was +5 plus 2, which corresponds to 0, 1, 0, 1 plus 0, 0, 1, 0. So we start from here, and that's a 0, 1, 0, 1. And starting from here, we have 0, 0, 1, 0. So that is 0, 0, 1, 0. And you can just see our display here corresponds to 0 for our positive negative sign bit MSB all the way on the left, with 3 ones, which is corresponding to a positive 7. So 5 plus 2 equals 7. That's correct. For our next example, we had -5 plus 2. So for a -5, the first thing we'll have to do is turn on our -8. So -8 plus 3 is a -5. We're going to add to that again a +2. And as you can see in our result here, we end up with a negative. There's the sign bit, -3. For our next example, we have +5 plus a -2. So we'll go back to a +5 plus a -2. I got that wrong. So we have a +5 here, plus a -2. One, 0, 0, 1, 0, 1. And as you can see here, we end up with +5 plus -2, which is a +3, and we have that, and there is a carry out, but that's ignored. For our next example, it's going to be a -5 plus a -2, which should yield a result of a -9, or -7. -5 plus -2, -7. Okay, so to achieve our -5, that's going to be 3 plus -8. There's our -5. And then we're going to have, for our -2, we're going to have 0, 1, 1, 1. That's -8 plus 4 plus 2 to give us a -2. And as you can see here, the total there will be a -7 because you have a -8 and a +1. So that's a -7 again with a carry out that we're ignoring. I also added a overflow detect. So I'm going to do one example of an overflow detect for an addition problem. And for that, I'm just going to add a +7 to a +2 so you can see the overflow flag. So we're going to do the +7 first. There's our +7. Here's our +2. And as you can see, our display here is giving us a result of a -7, when our result should be a +9. And that's because we do not have enough bits, so we've gotten an overflow. So I made this light here an overflow flag that'll display whenever we have an overflow error. Okay, now we're going to run through our subtraction problems. We're going to start with +5 minus +2. The first thing we need to do is set our first dip switch up, and that just makes the circuit into a subtraction circuit. So again, we're going to have 5, that's 1, 0, 1, 0, 1, and 2, 0, 0, 0, 0, 1, 0. And as you can see here, +5 minus +2 is a +3. So we're correct there, and we do have a carry out. Next, we're going to do a -5. Sorry, I switched that subtraction selector. I had to put it back on. Okay, so we're going to do a -5 and a positive minus a +2. And as you can see, you have a -8 and a +1. That's a -7, so that's correct. Next, we've got a +5 minus a -2, which is the same basically as saying 5 plus 2, but in this example, we're going to do it the other way around. So we need our +5 first, and then our -2. And as you can see, the display here, let's see, 0, 1, 0, 1. We have a -2, yeah, 0, 1, 1, 1, which corresponds to a +7. Oops, I keep switching that one. Okay, and finally we have a -5 minus a -2, which should result in a -3. So we go -5 first, and then a -2 again. And as you can see, you have -8 plus 4, which is a -4, plus 1, which is a -3, which is our desired answer. And we will run through one more overflow detect. So for here, I'm going to do a -8 minus a +2, which should result in a -10, but because we don't have enough bits to signify that in Sign 2's complementary form, we end up with an overflow as well as a carryout. So you can see the carryout here and the overflow, and it's displaying a +6, which we know is incorrect because of the overflow bit. Okay, thank you very much.